Today we are discussing about Prim's algorithm in DA, Design Analysis of Algorithm. What is Prim's algorithm? Prim's algorithm is useful for calculating minimum cost spanning tree. Means we can calculate the minimum cost of a spanning tree. And spanning tree is a subgraph of given graph. In given graph, spanning tree means it is a subgraph of given graph. Spanning tree should produce minimum cost than other remaining spanning trees is known as minimum cost spanning tree. Means it should produce some cost. So, Prim's algorithm, we can start with any vertex. Start with any vertex of the graph. We can start from any vertex of the graph here. So, we have to find out all the edges associated with that vertex. So, if we select one vertex as A, so we have to select all the associated vertices. Means here associated vertices of A is C and B. So, we have to select this. And from the available edges, select the minimum cost and add that edge to the tree if not forming any cycle. If it forms cycle, discard the edge. So if we select one vertices, it adjacent edges are C and D. So we have to take minimum cost from these two vertices and we have to add to the tree if it is not forming any cycle. If it is forming any cycle, we have to discard that edge. Okay, this is Prim's algorithm. So now here we are taking one example. Now here we are taking one example of Prim's algorithm. Here we are taking A, B, C, D, E. That means 5 vertices we are taking. We are taking 5 vertices and we have 6 edges. These are vertices. These associated lines are called edges. Okay? Edges. So we have cost A, B, C, D, E. So from A to B the minimum cost is 7. A to C minimum cost is 3 and C to B minimum cost is 4 and C to D minimum cost is 10 and B to D minimum cost is 9, B to E minimum cost is 11. So we have to find out the minimum cost for the spanning tree. Okay. So here the property. So we have 3 main properties in to find out minimum cost of a spanning tree. So these are 3 steps. 3 properties. Spanning tree should contain all the vertices of the graph. So we are forming a spanning tree. So that spanning tree should contain 5 vertices, all the vertices of the graph. But if the graph contain n vertices, if graph contain n vertices,